Alright, in this video I'm going to show you how you can solve an integral using the integration by parts method, and I'm also going to show you how you can use the LIATE technique to set your u and dv variables. So what you want to do when you're solving an integration by parts problem is break the problem into 3 steps. The first step is to recall the formula for integration by parts, and the integration by parts formula states that the integral of u dv is equal to uv minus the integral of v du. And what we're going to do is we're going to set one of the terms from our integral equal to u, and the other term in our integral equal to dv, and then we'll then differentiate the u term to find du, and integrate the dv term to find v. So step 2 is to set u and dv, and that's where we use the LIATE technique. What LIATE says is that the term in your integral that's closest to L can be used as u, and the term in your integral that's closest to E can be used as dv. So in our particular problem, we can see that we have an algebraic being multiplied by a trigonometric expression. So referencing our chart, we can see that algebraic is closest to u, and trigonometric is closest to dv. So with that, we can see that u is equal to x, and dv will be sine x dx. And don't forget your dx so that you can integrate. So differentiating x, that gives us 1 dx, and integrating sine x gives us negative cosine x. And you don't need to add the plus c here, you'll just need to add it in the final stage of the problem where you solve. So now that we have our variables, we can move on to step 3, which is to solve. So we have that the integral of u dv is equal to uv, which is negative x cosine x, minus the integral of v du, which is negative cosine x times 1 times dx. And simplifying, we get that the integral of u dv is equal to negative x cosine x. We have 2 negatives, so positive integral cosine x dx. And we know that the derivative of sine x is cosine x, so therefore the antiderivative of cosine x is sine x plus c, and that gives us our answer. So that's how you can solve an integral using the integration by parts method in conjunction with the LIATE technique. If you found that helpful, go ahead and leave a like. If you have any questions, go ahead and leave a comment and subscribe so you can see more. Thank you.